Okay, I think we are ready to get started. So welcome everyone to this webinar, How to Leverage AI for Feedstock Management. Before we get started, there's just a few things I want to go over. First, all of you are on mute. Second, we are recording this webinar, and so I will be sending out the recording tomorrow afterwards, and then I will also be putting it on our YouTube channel. We are going to have a live Q&A at the end, so as you think of questions during the webinar, go ahead and pop them in the Q&A button at the bottom of your Zoom screen. And last, I would just like to introduce our presenters today. We have Sam Kratke, who's our account executive here, and then we have Samir Kamat, lead solutions engineer. And with that, let's just dive right in.
Thanks, Sam. Let's dive right in. So the agenda for today is to look at the supply-demand relationship for recycled materials. We'll also talk a little bit about the challenges with feedstock supply. And once we understand what the pain points are, we'll elaborate more on our Recycle OS solutions to combat feedstock issues, supply challenges. And towards the end, we'll leave some time for Q&A. Next. So let's talk about how and why the demand for recycled content is going up. Let's start with the company pledges. About 86% of consumer goods companies have pledged more recycled content in their packaging. And some of these companies include Unilever, Procter & Gamble, PepsiCo, L'Oreal, Mattel, and so on. By 2030, they estimate more than 25% of packaging to be of recycled plastic. The interesting thing to note here is that the consumer behavior is also changing very rapidly. About 70% of consumers are willing to pay more for recycled products and sustainable packaging. There is also an impact on climate, which is recycled feedstock requires way less energy than virgin material feedstock, and reducing that by 11 gigatons of CO2 equivalent emissions by 2050. With a lot of EPR laws coming across different states in the States, there is going to be a more mandate around using recycled content, incentivizing higher recycling and recovery rates. Next. While the demand is understood, let's look at how the supply is looking over time. So currently, the price of recycled PET is more expensive than the virgin plastic. And that is mostly because of increase in processing costs for the reclaimers, as well as due to low supply of material. If you look on this graph right here, this was a study done by McKinsey in 2023. In 2024, where we are today, the supply is keeping up with the demand, and that is about 2,000 million pounds of PET produced in 2023. However, what the studies indicate is that the demand for rPET goes up 15% per annum, while the supply is going up only by 1%. The green line here in the right chart indicates the how the supply is going to look like. And as you can see, these are estimates just based off of 50% of companies who have actually pledged to use sustainable packaging. And by 2030, this demand is going to be at around 5,000 million pounds, while the supply is still going to hover at about 2,500 pounds. So the supply is going to be nearly 50% of what the demand is going to be. Next slide. So what are some challenges with feedstock supply? At the post-collection sorting stage, a lot of MRFs face issues with labor challenges that lead to high cost and low quality bales. Imprecise sorting equipment and lack of visibility also leads to sorting losses. There is, because of the current machinery, there could be some contamination in the feedstock. And then because of this, it results in a poor bale quality that leads to revenue losses for the collection centers. The material is then hauled over to the secondary processing facility where this bale gets converted into pellets. And due to the shortage of high quality feedstock, this leads to high cost of processing. A lot of times there is contamination of different materials, metals, and so on, and items that are really not supposed to be present there. And that leads to high processing costs and downtime for the reclaimers. This low quality bale also leads to lack of consistent output, which also it leads to missed revenue potential. So if we were able to ideally recover all this lost material from the MRFs, and if we are able to provide high quality feedstock to the reclaimers, we would be able to process high quality output that would in turn lead to low processing costs for the reclaimers as well as low downtime, which would result in a future where the cost of recycled PET would be way less than that of virgin material, and that would further drive up the demand. Now, in this slide, we have focused mainly on PETs, but this is also applicable for aluminum, HT, polypropylene, and other materials as well. Now, I'll have my colleague Sam Cracky, who will go deeper into understanding and explaining what are the different solutions that we provide that can help combat with these challenges with feedstock supply. Thanks, Sam. Over to you.
Thanks, Samir. Before we dive into solutions tackling the challenges of feedstock management, I'll provide a quick overview of EverestLabs for those who are not familiar. EverestLabs is a climate tech company based in the Bay Area, bringing enterprise AI software and automation to the recycling industry. We're focused on developing technology to drive efficiency and profitability for our recycling partners. Our solution, called RecycleOS, empowers MRFs and recyclers to increase recovery rates on material in order to reuse recyclables in manufacturing. Our automation solutions and robotic solutions drive cost savings and allow operators to minimize or remove the need for expensive contract labor. And they provide sorting and quality control in places that didn't previously have sorters due to staffing difficulties or the layout of a line, such as an incline belt. Lots of times we see facilities with lines that are half-staffed, which doesn't provide optimized recovery. Our RecycleOS solution allows sorting lines to be staffed 24/7 and consistently perform efficiently. And we also have a robotic operations center that's constantly monitoring our installed robotic systems so that there's absolutely no downtime and you don't need to babysit your robots. If there's anything that our team notices, like a suction cup that needs to be replaced, we'll alert your facility maintenance team via a text chain. So it's very easy and hands-off. Next slide. To break down the RecycleOS system, we have a two-part package which is installed on your line, a vision system and a robotic arm. As material comes down the line, our vision system uses image recognition technology combined with machine learning and an AI algorithm to detect each object. And that data is collected and stored in a dashboard that you have access to. This dashboard is completely customizable and tracks metrics that you're interested in seeing, whether it's contamination percentages of each material, bale auditing reports, or avoidable disposal fees. Simultaneously, the vision system recognizes which material on that line shouldn't be there based on how it's programmed and what's contamination. And our robots will then pick up that material and place them on another conveyor belt or into a designated drop area. This solution provides value to both post-collection MRF as well as plastic, aluminum, and paper recyclers. Next. The first way to leverage AI for feedstock management is through viewing the composition of the material that's actually coming through your plant. Having our AI camera operate during all the hours of the recycling facility shifts allows our customers to have constant access and visibility on their operations. We can identify over 50 different recyclable material classes, and this is continuing to grow in a database. We can look at identifying contaminants such as PVC, and we can not only track contaminants, but break down granular color distribution within specific types of plastics, whether it's black or colored, white or natural. And we can also look at identifying FDA versus non-FDA grade material for polypropylene. This AI data coming from our vision system allows operators and plant managers to have the feedback and evidence to back up investments in their plants for sorting and quality control improvements, as well as provide real-time feedback to their suppliers. Next slide. The recycling facilities that we work with, whether it's in metal, plastic, or paper, have direct lines of communication with their suppliers and broker deals based on the price of commodities and the purity of the bales that they're receiving. Before using our AI system to quantify this, there was really no good way to truly measure the quality of the incoming bales. Across the board, we talk to customers that are doing what it takes to comply with regulatory requirements by doing manual audits. This is very labor-intensive work. And on the AI and data side, this is where our product can drive automated solutions. RecycleOS is a platform that fundamentally starts with an AI capability software. And from this, we've created data and analytic offering that gets real-time insights for our operators and plant managers and brings structured data to you very quickly. These are curated reports that are automatically created representing feedstock from each supplier that you have. And this can be customized to represent that data hourly, daily, or monthly, whenever you're processing these bales. Using this data, recyclers are able to understand their input feedstock and their yield output. And based on this information, they can also determine where there's opportunity to remove contaminants in order to produce a higher yield quality. Next slide. As previously mentioned, the second part of our robotic RecycleOS solution is a robotic arm. And we can use this solution to help recyclers who have large sorting challenges. The data obtained with the AI system allows us to drive our robotic solution to optimize sorting and provide value by reducing labor costs. So these robots are used in place of human sorters and in places where you might not currently have sorters for quality control picking. Due to the accuracy and consistency of the robot's performance over the course of 1, 2, or 3 shifts, facilities are able to process material much more efficiently. One of the facilities that we work with used to actually stop processing new feedstock a couple days a week so that they can rerun the material that wasn't sorted with their manual labor. With robots, we're able to remove the need to rerun the material through the facility. We can also increase the quality and quantity of your throughput by allowing facilities the opportunity to purchase more feedstock at a lower quality for less money and still maintain an equal quality output as previous. And finally, we can eliminate the opportunity for feedstock to not only contaminate a material stream, but actually cause problems downstream, which could shut down machines along the line so that there's plant downtime. There is a very high cost with a plant being down and needing to repair this heavy-duty equipment. And unfortunately, this is a very common problem that we see within recycling facilities. But we're able to actually use our robots to remove those contaminants upstream so that we can increase plants' uptime. Next slide. So to tie this back to what Samir mentioned earlier, there are shortages and problems along the recycling value chain that are all a domino effect. MRFs have very manual operations, so they can't increase their recovery while keeping their costs low. Then in turn, there's a lack of feedstock for reclaimers and recyclers, and so their costs are very high and they're unable to compete with the price of virgin material. And if costs are high for the manufacturers, they can't commit to programs where there's recycled content because they also need to meet cost goals and supply goals. And then this leads to the brands that actually want to use this type of sustainable recycled packaging unable to obtain it. This problem of feedstock shortage that we are facing is not going away, and in fact, it's growing. The nuances in which material to recover and how to recycle them is only going to get more complicated as packaging design and recycling collection evolves. And we're going to really need to rely on new technology rather than manual processes to solve this. And EverestLabs provides automation and data solutions to address these large-scale challenges at MRFs, recyclers, and CPG companies. And we can use RecycleOS to bridge the gap between the lack of data and manual operations that lead to operational inefficiencies across the value chain in order to further enable a circular economy. Okay, now I'll pass it back over to Sam Lindsay to open up for Q&A. Thanks, everybody.
Awesome. Thanks, guys. That was a nice short webinar, which I know we all love. So thank you for putting that together, Sam and Samir. We did have a couple of questions come in. So this first one, I'm going to send it over to Samir. It says this webinar talked a lot about PET and polypro, but what about aluminum and other metal recyclers?
Yeah, thanks, Sam. We can absolutely work with any metal recycler. In fact, today we are working with one of the bigger aluminum recycling companies. And if you are processing UBCs, aluminums, or just metals in general, let us know, and we'd be happy to do a free site survey for you to understand how we can help. But yeah, to answer the question, we can absolutely help.
Okay, thank you. Can you tell me a little bit more about what that site survey is and what that looks like?
Yeah, so we would be essentially coming in to understand how the material is processed in your facility. We'll, try to get a sense of, okay, how many tons per day do you do? What are the outcomes, objectives, that you are looking to address? And we'll try to get a deep sense of, understanding of your pain points and see if you have any issues with labor or with understanding material comp, audits, etc. And we'd basically look at the plant, look at how the material is processed, and then we'd put a report for you to say, hey, these are all the things that we could, these are the areas where we could help, and give you a sense of understanding of what does the model look like, what would you have to do, what would we have to do, and then we would work together in more of a partnership to get the problems resolved.
Awesome. Thanks, Samir. We had this question come in. They said, is your technology specifically for MRFs, or is it also applicable to ferrous and non-ferrous scrap processing?
Yeah, so the technology is applicable to MRFs as well as to secondary processing sites. And that also includes, reclaimers, and includes ferrous and non-ferrous plastics. So we provide basically a circular solution So right from the preliminary processing to the end processing, our solution is applicable to the end process.
Awesome, thanks. Okay, this one I'll send it over to Sam. So they want to know, do we need to get both the robotic arm and the vision system, or can we just install a vision system?
Yeah, great question. So there's two options that you can do. You can get our robotic cell, which includes the vision system and the robotic arm, or you can just get the vision systems as a standalone product. So we often see that a lot in some of these secondary recycling facilities where customers want to use the vision system to do bale auditing and just kind of identify the material that's coming in and out of the facility, maybe as a first step before they put robotic arms in, or just for the data collection alone. So it's definitely possible to just put vision systems within your facilities.
Okay, great. And then one more. I know, Sam, you touched on this a little bit, but maybe you could expand. Can you identify food grade versus non-food grade polypro?
Yeah, so that's something our system can look at, and our model as a whole is very adaptable. And so if there are specific items that you're looking to identify that we can't do at the moment, we can also train our AI module to learn how to do this. It takes a couple weeks, a pretty seamless process, and we can start to identify valuable objects for your facility. So yes to the food grade and non-food grade polypro. And if there's anything else that people are interested in as well, I think our product and engineering team would love to work with you on that.
Great. Let's see. So this person has a good question. Are your vision systems trained for non-morph materials such as non-CPG recycling? Maybe send that over to Samir.
Yeah, thanks, Sam. So, so we do not currently have that offering, but we can work with you on that. It might just take a couple weeks of more training. Like we would just have to collect more data sets, just analyze more of the material that you are processing, and we would be able to set the AI system up for your material as well. So I would say please contact us, and we'd be happy to discuss this in more detail.
Okay. And then another question came in. I'll pass this over to Samir. What's your experience using products to recover recyclable materials from MSW or trash?
Yeah, so as long as the material is well spread out, we can efficiently sort and recover the material. But generally, what we have seen in MSW plants is that the material is pretty piled up, one on top of the other, and there is very little the material spread is really not ideal in most cases, but we'd say if this is something that you're willing to work with us, again, please contact us, and we'd be happy to do conduct a free site survey. Come out there, take a look at your belts, see how you're processing it, and see if we can change some things to perhaps make our solution a better fit for your facility.
Yeah, I think too, this the person that asked that, if you wanted to send in some pictures or videos of specific lines you're looking at, we can also help answer questions that way too. I think we've reached the end. I don't see any more questions coming in, but again, if anyone has any questions, go ahead and reach out to Samir or Sam, or to me, the other Sam. And I will be sending out an email tomorrow with the recording to this for you to review or to share with your colleagues. And I would like to thank everyone so much for attending. And thank you to Sam and Samir for putting together all of this content. I hope everyone enjoys the rest of your day.